All right, I got a question about how to know where to draw the dashed lines when graphing Rose curves. So I'm taking the review guide here just briefly to indicate how you would do that. We have an equation here, r equals 6 sine 2 theta, and it's a rose curve with 4 petals because this is an even number 2 here, and 2 times 2 is 4, so we have 4 petals with length 6, because that's the amplitude. All right. So when drawing this, we draw the curve on the uh, r theta axes like this, r and theta, and then this is a petal, this is a petal, this is a petal, this is a petal. And so what happens is that when you're graphing, you start at the pole, and then you extend out. R gets bigger and bigger until you get to the max pole, the max petal height or length, and then you have to head back to the pole. But you have to head back to the pole before you get to this angle here. This angle is at the pole. It's 2 pi over 4, which is pi over 2. Okay, so what happens is that you draw your curve like this, and then you have to head this, and this is pi over 2 here. Okay, and so you have to make sure that your r heads back to the pole before you get to pi over 2. Okay, so let's see another one. All right, and then r starts getting bigger until you go out to, we're going to go to -6 here, because these, it looks like I have -6 here. And then you're going to rotate out from the pole, you rotate out to 3 pi over 4. 3 pi over 4. So from the pole, you're going to go out to 3 pi over 4, and then you've got to get back to the pole by the time you get to pi, because that's 4 pi over 4. Well, this is pi. I say pi. If I'm measuring from the left side, this is pi over here. So you have to be back to the pole before you get to pi, the angle pi. Okay? And then you're going to go to the next point. When you're out radially 6, you have to end up here. You go out radially 6 and rotate to 5 pi over 4 from the pole. Now I have some overlap here, but you rotate out and then back to the pole, but you have to be back to the pole before you get to 6 pi over 4, 3 pi over 2. And this right here is 3 pi over 2 if you're measuring from positive. So you have to swing out and then be back to the pole, meaning you can't swing out and go beyond 3 pi over 2. Okay, let's look at number 7. Number 7 says -7 cosine 3 theta. All right, well, we start off the pole and to the left because we have a -7 here. And then we have to be back to the pole before we get to the pi over 6 angle from this direction. So this is the pi over 6 angle. And you see when I drew it, I had a little bit of overage. But so the pole is at pi over 6. So you swing out until you get to about the pi over 6 line, and then you have to make sure you're to the pole by then. And then you go over to your next point, which is going to be at 7 pi over 3. So you put your point out here, and then you swing out, and now you're coming, and this angle here is the pi over 6 angle. And you're coming out from there and going up, and then you have to be back to the pole before you get to 3 pi over 6, which is this here, pi over 2. So you swing back to the pole before you get to pi over 2. Okay. Then let's do the next one, which we're going to start at -7. And that's, what does that say? 2 pi over 3. So that's, I mean, that's 4 pi over 6. I'm sorry, it's early. 4 pi over 6, which is 2 pi over 3. So you're going to swing back out here. So you're going to pass through the pole, come out, hit your max petal length. And when do you have to be back to the pole? You have to be back to the pole by 5 pi over 6. And again, I have some overage here, but this is the 5 pi over 6 line. And we really should be back to the pole by the chance we get to 5 pi over 6. Okay, so that's how you draw the lines. the dashed lines that I use as guides. All right, what about this negative 8 cosine 2 theta? Well, we're going to start off the pole again to the left. And then when do we have to be back to the pole? By pi over 4. And that's how we draw this line, pi over 4. I did a better job of getting back to the pole before you get to pi over 4. And then the next point you're going to go to is 8, swing out to pi over 2. And then what happens is that you start realizing, okay, these are my kind of guidelines here. And those are the fourths. That's when you're at the pole. And so you have to come out of the pole and back into the pole within these two zeros, if that helps. And that's how I draw my lines. Now let's talk about the circle. Well, I have my zeros at 0, pi, and 2 pi. And so this is the 0, pi, and 2 pi line. And so I start out at the pole because this is a sine curve. And I have to swing out to my max, in this case diameter, at 8. And I swing out to pi over 2, or rotate to pi over 2. And r is getting bigger until I get to pi over 2. And then I have to be back to the pole by the time I get to pi, which is here. And so I'm back to the pole before I get to pi. Okay? And so this one just has one line. Okay. Lemniscates are much the same here. What are my zeros here for the first lemniscate? The first lemniscate has a 0 at pi over 4, so we're starting at the pole. And then I have to be back to the pole before I get to pi. So that's how I know that I start on the pole, and then I have to be back before I hit. So the lines here are here. Now I just have this line here drawn because that's my symmetry. And mine should be even probably bowed out a little bit more because I'm, the pi and 0 angles are the 0 and the pi over 2 angles are my ones that I'm approaching as r gets back to the pole. Right? And then this part of the lemniscate we don't draw because we can't take the square root of a negative number. And then we start again at the pole here, and then we rotate out. We go 3 to 5 pi over 4, so we're going to end up here. But when do we have to be back to the pole? We have to be back to the pole by 3 pi over 2. So our curve has to go back to the pole before we get to 3 pi over 2. And this here is 3 pi over 2. All right, so let's try this lemniscate. Let's see what my angles are here. Well, when do I get to the pole? I get to the pole here at pi over 4. So I'll draw pi over 4 here. I did a better job on this one. Okay, so what happens is I start off the pole and out, and then I rotate nothing, and then I have to be back to the pole by pi over 4. So I drew my little pi over 4 dashed line, and I have to be back to the pole by the time I get there. Okay, and then I am in a holding pattern until I get back here, and I'm at the pole, and then I have to rotate out 4 to pi. So I'm going to, go out here, and then I have to be back to the pole by 5 pi over 4, this is a 5 pi over 4. So I go out with my pi over 4. I go out close to pi over 4, get to my max pedal height here, and then I have to head back to the pole before what angle? Before 5 pi over 4. And this is the angle 5 pi over 4. Okay, and then I'm in a holding pattern because I can't take the square root of these negative numbers. And then I start at the pole and I have to swing out into, I get back to 2 pi. And I'm swinging out from the angle 7 pi over 4 to the pole. And that kind of gives you what your curve has to lie between. All right, so I hope that helps, and you have a good rest of your day.